Hello guys, welcome back. Hopefully you're all right and wearing a mask. And let's go. We're gonna go with the fundamental physics, the third chapter. We're gonna go with kinematics in 2 dimensions and vectors. Don't forget, we have done this a lot of time. And the last courses such as calculus, linear algebra, I think we have used in the computer architecture too, so no problem, don't worry. This is a safe chapter. We're gonna begin with vectors, blah blah blah, addition, subtraction of vectors, dating vectors, projectile motion. This is really cool. Solving problems, projectile. Blah, blah, blah. So the vectors we know as a magnitude as well as direction. Some better quantities we have displacement, velocity, force, and momentum. While a scalar has only a magnitude. Some scalar quantities we have mass, time, and temperature. As you can see, scalar has only magnitude. Scalar has only magnitude. Here we have the addition of vectors. We have graphical methods directly here. The data they judged 8 and 6 give us 14 kilometers on the east side. Why this is not done on the other side? Because 8 minus 6 give us only 2 kilometers of the resultant. For vectors in one dimension, simple addition and subtraction are all that is needed. We don't need to be careful about this. Of course we need to be careful about the sign as the figure indicates, because this is, I said, this is plus. You use plus here, but we here use minus. If the motion is two dimensions, the situation is somewhat more complicated. Here the actual travel paths are the right angles to another. We can find displacement by using Pythagorean theorem. This we know. We can use over c squared is equal to a squared plus b squared, and later on we can use the square root to simplify the c squared, which is the same thing right here. Yes, we have done this resultant because it's the result of d1 plus d2. d1 plus d2 is equal to the distance resultant. So adding the vectors in the opposite order gives us the same result, of course. As you can see, we have d2 and d1 give us dr. So it is done here, but let's do it because you have to learn step by step. Even while it is tiring, but to do it. As you can see, v1 vector plus v2 vector is equal to, it's the same as v2 plus v1. Oh really? No way. How could you? As I said before, guys, I know these like PowerPoint things are really tired. Like, come on, it's 2020, do something better. Okay, if the vectors are not at right angles, they can be added graphically by using the tail to tip method. Oh yes, we use here, and later on, if you like. Let's see how it goes. v1, and it goes all the way down. Then we have v3, something like this, but this will give us this case, and it would be better to use another sign. So this is the tail to tip method. Because this is another sign, okay? We've done here. This is the resultant of it. This is the VR that I did like bad, but no problem. This is V2, this is V3. The important here is that you have the motion of what is tail to tip method. Yes, as I said, V1, tail to tip, tail to tip. Tail to tip will give us, and of course we have to do VR here because it seems that he's cool, and we do it. Even more 2005, it is still like cool guy. And the parallelogram method may also be used. Here again the vector must be tail to tip. Okay. So let's use V1, V2. But as you can see here, don't forget, Okay, don't forget this one, because we'll learn it from the linear algebra. What we do here, we go from 0, which is the destination, the origin, and we come close to that. Pop up. Yes, perfect. Yes, and give a like this. This is the VR, this is V1 and V2. This is a parallelogram. Okay, this can be accepted to... Yes. As we learn from the vectors in the linear algebra, we did this too. And later on we can do it like that, blah blah. Yes, perfect. And this is in the wrong side right now. Yes, we couldn't do like that. No, this is not the tail to tip method or the parallelogram method. This is like tail to tail method. Nope, don't do it, don't never see this one, okay? This is wrong. Check this one. These are so cool, these are so pretty. Okay, in order to subtract the vectors, we must define the negative of the vector which has the same magnitude but points in the opposite direction. V minus V1 give us 0 here. Then we add the negative vector V2 minus V1 is equal to V2 plus the negative vector V1, and give us like this: V2 minus V1. This would be the result of it. Now the vector V can be multiplied by scalar C, of course. Don't forget, scalar has only magnitude, while a vector has magnitude and direction. This is more properties, this is only one property. I don't like this one. The result of vector CV, that is the same direction, but the magnitude of C of V, if C is negative, the result of vector points in the opposite direction. Yes, V2 is 1.5, and vector 3 is negative 2. Like 3.5, yes. Any vector may be expressed as the sum of two other vectors, which are called its components. Usually other vectors are chosen that are perpendicular to each other. Okay, we can do it here, we can do like here, and yes, we can find the theta degree here. This is over 30 degree. Okay, perfect. It's done this case, no problem, sorry. Yes, I said it before. It's done here, and then find the degree. If the components are perpendicular, can be found using trigonometric function. To find sine theta, we use Vy over V. To find cosine theta, we use Vx over V. To find the tangent theta, we use Vy over Vx. And yes, we have V square is equal to V2 is equal to V2x plus V2y. Sorry. The components are effectively one-dimensional. They can be added arithmetically. To add a vector, we have draw, choose, resolve, calculate, add, and yeah. And of course, don't forget, to find the length and direction of the vector, we use this is a formula of vector to find the length and the direction. This is only for the tangent, because tangent is like sine over cosine. If I'm correct, it's sine over cosine, so I use Vy over Vx. And to find the length direction of vector, it's easier here. We use the Pythagorean theorem, don't worry. Which is over c squared is equal to a squared plus b squared. And to simplify this, we use c is equal to a plus b. And this guy has done the same thing. Huh? Don't forget. Don't make this complete. This is the same thing. Only this is like more attributes and more properties. This is v2 of x and this is v2 of y. X and y axis. Oh yeah, here's the coolest part. Here, projectile motion. Projectile is an object moving in 2 dimensions under the influence of Earth's gravity. Its path is a parabola. As we know, g is equal to 9.8. So this is a point, 9.8 meter per second square. And of course, we can see here the parabola. Okay, let's do it like this way, no problem, I don't mind. This is a negative x squared. Of course, this can be added to negative x squared too. This is the ball bouncing here, okay? Okay, I think that I don't have time for that, so sorry. I'll try to be really quick. If you would like to check it for yourself, as you can see here, it is way more easier to do it like that. This is a negative s squared, so we can find here is the parabola that this guy is saying. Don't forget, g is equal to 9.8 meter per second squared. Okay, of course it can be understood by analyzing the horizontal and vertical motion separately. If we drop it vertically, you will have no problem at all, be directly there. Of course it is separate from the horizontal side. We don't have to analyze it with the x and y components. While in horizontal, this is called as a projectile motion now. As we drop it, we analyze the v0, x, we have an x and y properties, and vr, and of course vy and x properties, and then the v, and how it goes, and blah 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 blah. And of course later on we can check how easier it is to find the degree of this in the theta sign, as from the formula we will learn. And of course acceleration a is equal to the gravity in this case, which is because the earth attracts it from this 9.8 meters per second square. The projectile motion, the speed is in the x direction is constant. Okay, in the y direction the object moves with constant acceleration g. Okay, this is a photograph that shows two balls that start to fall at the same time. The one on the right has initial speed in the x direction. It can be seen the vertical position of the two balls are identical at identical time, while the horizontal position of the yellow ball increases linearly. If an object is launched at the initial angle of theta 0 at the beginning means, with the horizontal the analysis is simpler, except that the initial velocity has a vertical component in this case. So yes, let's analyze them all, and we can be done like this by all the way down. But of course we choose, because in this case it is 0 at this point. This doesn't have to do it anymore. You know, yeah, we have learned it at the calculus, right? Maybe use the derivative there. It's so easy, don't forget. And Vy in this case, the Yx in this case is 0, because it is the highest point it arrives, and later on it decreases. And they analyze the object moves, Y and X properties. Later on we can find to the end where it is. Okay, you have to solve problems involving projectile motion. The projectile motion is motion with constant acceleration in 2 dimensions, where the acceleration is g and is down. Here is a table of equation projectile motion. Y is positive upward, x is equal to 0, and y is negative g, or 9.8 meter per second square. Horizontal motion is equal to ax is equal to 0, vx is constant. X is equal to x0 plus vx0t, and the vertical vertical motion is a of y is equal to negative 9.80 meter per second squared. Is equal to constant gravity. Blah blah v of y is equal to y0 minus gt, y is equal to y0 plus vy0t minus 1/2 gt squared. Vty is equal to vty0 minus 2g and y minus y0. How to choose the problem: read, drop, choose, decide, and examine. Who list and plan? Oh guys, you can do this with everyone, whatever you're comfortable, so don't listen. In order to demonstrate the projectile motion, we use those fireworks here, or the everything in the world, in the real world. But we find that y is equal to ax minus b of x squared. This is the equation for parabola. For relative velocity, we already consider relative speed in one dimension. It is similar in two dimensions, except that we must add and subtract velocities as vectors. Each velocity is labeled first with the object and second with the reference frame in which it is as this velocity. Therefore, v of ws is velocity of the water in the short frame. It is the velocity of the boat in the short frame and the velocity of the boat in the water frame. In this case, let's do the relationship for three velocities. This is boat water and SW, BS, B speed. And the current is in this case, so the current will be on this side. So to find the VBS, you're using it as a VBY plus VWS, and this because of the river current, what will give us. And later on, we can find the resultant there of VBS. Is a summary. We've learned about quantity magnitude and direction of vector, quantity direction of scalar. We learned about Vectors and Scalars, vector addition and subtraction, the sum, resultant vector, projectile motion, and relative velocity. So this is the end, guys, and the story of this week, and have a great time. Goodbye, bye bye, cheers, bye bye.